Hello, this is Mrs. Boots, and let's look at some real-world radical problems. And so these are situations in which we have modeled data based on a square root function, which is really kind of cool. So we have two examples that we're going to work through that have the words and the real-world problems, and then we just have an example that only has numbers, okay? So in example one, we have new stars forming inside an interstellar cloud of gas. So when the fragments clump together, the mass is greater and it's known as Jean's mass. Really cool. So that's represented with the M sub J. That's Jean's mass. And they give us an equation for Jean's mass, but if you'll notice there's three variables. So we got to figure out what's going on. T is the temperature of the gas in degrees Celsius. Okay. N is the density per cubic centimeter. And then the astronomer discovers that with a mass of 137, he wants to know what the temperature is. Now, they gave us an N value of 1,000. So what we're going to do is we're going to use that 1,000 for all of the data points. So plug in 1,000 to start with for the N value. All right? So T is in degrees Celsius. And we're going to plug in this T into our equation. Now, for some of you, you may not know how to do this in the calculator. Super easy. It's not a big deal. Okay? So what I want you to do is we're going to step this through, okay? So first thing I'm going to do is I'm going to take negative 263 plus 273. Okay? I'm going to hit enter. Get an answer. Well, that's 10. Okay? Now I'm going to cube it. I'm going to raise it to the third power. Okay? That gives me 1,000. Then I'm going to divide it by 1,000. That gives me 1. Then you take the square root of 1 and you multiply it by 100. Okay? So that gives me 100. So you can step it through or you can plug it into y equals and do it all at once. I'm going to write the values up here. So for 262, we get 11 cubed, which we would divide by 1,000, take the square root, and multiply by 100, and we get 115.4, okay? We're not going to go to that specific of a graph point, but it's nice to know. For 261, we get 12 cubed, yeah, which gets crazy because I can't do that one in my head. And we end up with 131.45. And with 260, we get 13 cubed. Okay? So we have 148.2. All right? So remember your number line. The graph on the page may be a little bit backwards. So negative 260 is actually the one closest to 0. Then you'd have negative 261, negative 262, negative 263, right? So you got to label your graph. Now, I'm looking at my y values, these masses. I see 100, 115, 130, 148. Okay, so I'm going to start at 100, but then I'm going to count by tens, okay? Just to make it easy. So I have 110, 120, 130, 140, and 150. Now, technically in science, they like for you to erase the line and put some little jig in here to indicate that you have skipped a whole bunch of numbers and that we're not writing every single thing down. We're skipping to this part of the graph. And that's okay. We can do that. Okay? So 263 was 100. So negative 263 is at 100. Okay? Negative 262 was at 115. So it's going to be about halfway. Then I've got 130 at 261. Scoot that over. It's about 130. And 148, which is really close to 150. Okay, this is kind of doing some little it actually goes up and starts to curve over and flatten out like a square root. But at the beginning, it's hard to see, okay? So this is my curve. Now, what did they ask us? They want to know for a mass of 137. Okay, so on my y-axis, where is 137? It's right about there, just under 140. So I'm going to go over 137, hit my curve, and then go down. Where would that be? Well, it's between 261 and 260, negative 261 and negative 260. That's an approximation. Now, we could solve it algebraically, and if you want to do that, that's fine, but we get into that in a later lesson, okay? Let's do 2 more examples. Same thing. Much easier equation, though. So in example 2, we're dealing with pilots. Woohoo! Okay, so yes, rocket science here. First was star clusters, now we're dealing with pilots, okay? So we have a distance, and we're approximating that distance to the horizon for our altitude. So we're trying to figure out our altitude based on the distance to the horizon. Now, I really doubt that the guys are that bored in the cockpit that they're doing these numbers, but when they're in school, they definitely do these calculations. So all we're going to do is plug each one of these in. So 3.56 times the square root of 0, 0, right? 3.56 times the square root of 1,500 is 137.88. 3.56 times the square root of 3,000 is 194.99. The square root of 7,000 is 297.85. And then the square root of 10,000 ends up with 365. Oh, 356. I wrote that backwards. Okay. Now we put those things on our graph. You get to determine the scale. All right? So obviously 0 is on there. I'm going to say this is 1K, 1,000, 2,000, 3,000. I should have made those closer together. That's okay. Right? 4,000, 5,000, 6, 7, 8, 9, 10. Okay? So you can move them closer together. You can keep them farther apart. Now my y's. I have a 137, a 194. That's almost 300. That's over 300. So I'm going to count by 50s, right? So there's 50, 100. There's 150. 200, 250, 300, and 350. Okay? Now let's put the data on. So 0 is 0. Awesome. 1,500. So that's halfway in between. We're going to go up to 137, which is about halfway in between. At 3K, I go up to almost 200. At 7K, I go up to almost 300. And then if it fits on your graph, you go almost to 356. That's probably a little off. Okay? That looks more like a square root function. We're going to do the exact same thing. Okay? We're going to approximate. They didn't ask us to approximate. Well, you got off scot-free on that one. So if I were to approximate, if they were to say, well, what is it when y is 250? So I would come over to 250, hit my curve, come down and see that that's a little bit above 4,000. Does that make sense? Yeah, it does. It makes sense. Okay, example 3. We have just numbers. We have this beautiful equation. You plug it in. Yeah, that's all you do. leave a space, so we have the square root of 12 minus 4 times something equals to y. Okay, what's the something? Well, they told us they want it to be negative 16. So we plug that in the calculator. 16 minus 4 times negative 16, and we get a number. Oh, that's a 12. Wow. So that would end up being 12 plus 64. We take the square root of it, and y is 8.72. 8.72. Easy. As long as you don't write the problem down wrong, you plug it in the same spot, in the right spot. What are we given here? Yeah, they gave us y. Crazy. But that's okay. So I have 8 equals square root of 12 minus 4p. How do I get rid of the square root? Yeah, you square both sides. So we're going to square both sides. Boom, boom. Okay. So now I have 64 equals 12 minus 4p. I'm going to subtract the 12, and I get 52 equals negative 4p. Divide by negative 4, what do you think? Negative 13. This is what we just did on the graph. We took a y value and found the x. We took an x value, found the y's. It's the same thing over and over. Go ahead and start with your problems in the practice.